Okay, so following on from the previous video then, today we're going to be looking at quadratic graphs, and these are slightly different to quadratic equations, but quadratic equations are certainly used in quadratic graphs. So quadratic graph is of the form y equals ax squared plus bx plus c, might be depicted as an f of x, a function of x, and then you're asked to plot or sketch y equals f of x. That's completely fine. But the idea is we have an x-axis, a y-axis, and then we have a very distinct curve that goes in our xy plane, and this distinct curve is called a parabola. So both of these are parabolas, or at least they're supposed to be. This one is what we call a positive parabola, because this occurs when a is positive, and this occurs when a is negative, and we call this a negative parabola. You might have learnt it as a U-shape or an N-shape, depending if a is positive or negative. A cannot be 0. Maybe I should put that as a little note up here. It cannot be 0, because if it was, it wouldn't be a quadratic equation. It would be, at best, a linear. We are under the assumption that a is not 0. So it's either positive, which gives you a positive parabola, or it's negative, and it gives you a negative parabola. Notice that this gives you the parabola, a curve in xy space, and it is different to ax squared plus bx plus c equals 0, which is a quadratic equation, which we've looked at in a different video. And this one has finite solutions. It can have 2. It could have 1 repeated solution, or it could have no real solutions at all. But the point is, if it does have solutions, then they are what we call zero-dimensional objects. They are finite points, whereas this is a one-dimensional object because it's a line, a curve, okay, a 1D object. Yes, in 2D space, but it's a 1D object. Okay. So we're going to have a very quick look at some algebra behind this, and then we've got some examples of what we can do to have a go at sketching some of these quadratic graphs. So y equals ax squared plus bx plus c. Well, if I set y to be 0, which is the equation of the x-axis, then we'll be able to find exactly where my quadratic curve, my parabola, will intersect the x-axis. So if I set y to 0, I will get back to the quadratic equation, ax squared plus bx plus c equals 0, and we can solve that using factorization, quadratic formula, whatever method you want, if it has solutions indeed, and these will yield the x-axis intercepts. Similarly, if we set x to 0, now x equals 0 is the equation of my y-axis. Okay, every point on the y-axis has the point x is 0. Then we end up with y equals c. All right, because that would be 0, that would be 0, and I'm left with y equals c. So I'll put y equals 0, no, y equals c, apologies. And this is my y-axis intercept. And the other thing that we can glean from this is the turning point coordinate. And to find the coordinate of the turning point, we take y equals ax squared plus bx plus c, and we write it in completed square form, which looks like a into x plus some other number, which you can work out in terms of a, b, and c. That's squared, and then plus some other number, which I'm going to call f. D and f are just numbers. We can obtain these, and we'll have a look at how we get to those in some numerical examples in a minute. But when you get it into this form, which is called completed square form, then we can see that the smallest value that the square bracket can be is 0, because you're taking a number and you're squaring it, so it's either 0 or positive. So the smallest it can be is 0, and that occurs when x equals minus d. Okay, because when x is minus d, this bracket is 0. And when x is minus d, then y is a times 0 plus f. So y takes the value f. Okay, if you decrease slightly from D, you will increase this bracket, which may increase or decrease overall, depending if A is positive or negative. But either way, you'll be moving away from what we call the turning point. Later on in the course, you'll meet something called differentiation, which is another way to get D and F in terms of A, B, and C using a calculus method. Okay, so that's enough for the algebra. Let's move on to some numerical examples. So here's our first one. We've got y equals x squared minus 4x minus 5, and we're going to have a go at sketching this graph. So first of all, I'm going to factorise the quadratic on the right, and that's to make it very easy to spot the roots of the quadratic. Now the roots occur when y is 0, so for y to be 0, either x is 5 or x is minus 1, which means I know that this quadratic graph is going to cross the x-axis at minus 1 and the x-axis at positive 5. It doesn't need to be to scale because it's a sketch, but it is good to have a rough scale to it. Where to cross my y-axis? Well, set x to 0, we'll get that y is minus 5. So that's down here at minus 5. And to get the equation of my turning point, I'm going to complete the square. So that's going to be x minus 2 all squared. So that's going to give me a plus 4. I don't want plus 4, I want minus 5. So I need to subtract 9 from that. So that's computed square form. If you're unsure how to factorise or go into computed square form, then I suggest checking out some videos or ask your class teacher for help for that. Okay, because it's a quadratic equation, it's positive, then we know it's going to be a nice parabolic shape. And try and get your parabola as parabolic as possible. Okay. There we go, I think that's not a bad one. And then don't forget to label the coordinate points. And we also label the turning point if you're requested to do so. So x is 2, because that's what makes this bracket 0. And when that bracket is 0, we're left with y is minus 9. So that's the turning point. And what you'll notice is that the x-coordinate of the turning point, 2, is halfway between minus 1 and 5. And it always will be. Okay, the turning point will always be halfway between the two roots. Okay. All right, so that's that example, and there's my sketch. Don't forget to label the x-axis and the y-axis as well. And if you're asked to sketch this curve, then you would get full marks for something like this. More often than not, you're not asked to necessarily put the coordinates of the turning point on, but if you are asked to do that, you must put the coordinates of the turning point on. Second example then, a little bit different. This is a negative parabola. Okay, we can tell that because my a value is now minus 2. You can have a go at factorising it, or you can have a go at completing the square to solve it. Or you can use a quadratic formula to find the roots, doesn't matter. So set y to 0. I'm going to use a quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac. Well, it's going to give me 3 negatives kicking around there, so it's a negative altogether. So it's 4 times 2 times 2. And that's all divided by 2a, which is minus 4. Okay, so those are my two roots, and they will come out to be half and 2. So my two roots are a half and 2. To find the coordinates of my turning point, we're going to complete the square on this. So to do that, I'm going to take the minus 2 out as a factor. So that's going to leave me with x squared minus 2.5x. I'm going to leave the minus 2 alone for a minute. Complete the square on what's inside there. You don't have to do it this way. There are many ways to complete the square. This is just my preferred technique. That's going to give me an extra 1.25 squared, so I need to subtract the 1.25 squared. Subtract 2, and now I can bring the minus 2 back in. So I get minus 2 into x minus 1.25 squared, minus, 1.25 squared, well, that's 5 over 4, so it's 25 over 16. I'm going to times that by minus 2, but the minuses cancel, so it's going to be 25 on 8. So plus 25 on 8. and then I've still got my subtract 2, which is going to be minus 2 into x minus 1.25 squared. And that is 16/8. So 16/8 minus 25/8 is plus 9/8, or 1.125. Okay, so now we can sketch it. We've got our coordinates of the turning point, which is where the x value is what makes this bracket 0, so it's 1.25, and the y coordinate is here at 9/8. So I now have enough information. I know my roots are at 1/2 and 2, so there's my 1/2, there's my 2. It crosses my y-axis at minus 2, okay, going back to the equation right at the start. When x is 0, y is minus 2, so it's going to cross down here somewhere at minus 2. And now I just need my parabolic shape. Negative parabola this time because it's a negative 2 at the beginning, so it's going to look something like this. Okay, not a great parabola this time, but get the general idea. My roots were at 2 and 1/2. It crossed the y-axis at minus 2. My turning point here was 5/4, 9/8, and we can see that 5/4 again is bang in the middle of the 1/2 and the 2. Okay, it's 3/4 above 1/2 and it's 3/4 less than 2, so it's right in the middle. And that's my sketch. And of course, don't forget to label the x and the y axes. So there's my sketch of that quadratic graph. And one final example, which I wanted to show you this one, because this one doesn't have any roots. So we get to this one and we say, hold on, let's just try and solve y equals 0. This tells us that x equals minus b plus or minus the square root of b squared, 64, minus 4ac, so that's 4 times 2 times 11. All divided by 2a, which is 4. That's going to be minus 2. Okay, minus 8 divided by 4 is minus 2. Plus or minus, well, this is going to be 88. 64 minus 88 is minus 24. So we've got plus or minus root 24 on 4. But we've got a negative root in there. So the square root of minus 24. Well, if you do further maths, you'll understand. But for just the A-level course, we say, well, there's no roots. Okay, no real roots. I put real in brackets. So no real roots. So when we come to sketch it, we know that it's not going to reach the x-axis. It's a positive parabola because it's a positive 2 out front of the x squared. Therefore, it's going to sit above the x-axis for all x. It's going to cross 11 on the y-axis because that's the value of y when x is 0. And we can complete the square to find the coordinates of the turning point. So y equals 2 into x squared plus 4x plus 11, 2 x plus 2 squared minus 4 plus 11. So that's going to be 2 into x plus 2 squared. That's going to be minus 8, plus 11 is plus 3. And we can see that the coordinates of the turning point here are minus 2, 3. And because the turning point, the minimum, is above the x-axis, it's never going to get to the x-axis. Okay, so the minimum's at minus 2, 3. So minus 2, 3 is maybe, I don't know, here-ish maybe. It's better to draw your curve in and then label your points. So here we have minus 2 here we have 3 here, and here we have 11 here, because that's the value when x is 0. Okay. Don't forget to label your x and y axes, and then that's the sketch of y equals 2x squared plus 8x plus 11. That is enough detail for the full marks. Okay, thank you.